Hello everyone, I'm Shreya from Sri Venkateshwara College of Engineering, studying in second sem Department of Electronics and Communication. Now I'm going to discuss about a topic in maths, that is verification of convolution theorem. So firstly, introduction to convolution theorem. Convolution theorem is a fundamental concept in signal processing and mathematics. It states that the Fourier transform of convolution of two functions is equal to the product of their individual Fourier transforms. This theorem has wide application in areas such as image processing, communication system, and audio signal processing. Convolution operation. Convolution is a mathematical operation that combines two functions to produce a third function. It represents the overlap of one function as it is shifted over another function, multiplying and summing the overlapping portions. Convolution is commonly used to model the effect of linear time invariant system on input signals. Fourier transforms. Fourier transform is a mathematical tool that decomposes a function into its frequency components. It converts a function from the time domain to the frequency domain. Fourier transform is defined as an integral and can be computed using various methods such as the fast Fourier transform 50 algorithm. Now we will discuss about convolution theorem statement. Convolution theorem states that the Fourier transform of convolution of two functions is equal to the product of their individual Fourier transforms. Mathematically, if f of x and g of x are two functions and f of w and g of w are their Fourier transforms, and the convolution of f of x and g of x is given by f of x, g of x and its Fourier transform is f of w. Now, verification of convolution theorem. There are 4 steps in verification of convolution theorem. So firstly, step 1. Compute the Fourier transforms of the two functions f of x and g of x individually. Use appropriate methods such as the Fourier transform integral or f of t algorithm to obtain f of w and g of w. Perform the convolution of two functions f of x and g of x using the convolution operation. Multiply the sum of some overlapping portions of f of x and g of x as they are shifted relative to each other. And step 3. Compute the Fourier transform of the convolution result obtained in step 2. Use the Fourier transform integral or f of t algorithm to obtain Fourier transform of convolution which is denoted by f of w and g of w. And finally, step 4. Compare the Fourier transform obtained in step 3 with the product of individual Fourier transform obtained in step 1. If they are equal, then the convolution theorem is verified for the given function f of x and g of x. Application of convolution theorem. Convolution theorem is widely used in image processing for application such as blurring, sharpening, and edge detection. It is also used in communication system for channel equalization and modulation or demodulation process. In audio signal processing, convolution theorem is utilized for effects like reverb and echo generation. Conclusion. Convolution theorem is a powerful tool that simplifies the analysis of linear time invariant system and signal processing operations. By verifying the theorem, we can ensure the correctness of various convolution-based operations. Understanding and applying convolution theorem is essential for anyone working in the field of signal processing related domains. Thank you.